Hello students, so we will see few MCQs on electric charges and fields. So first one, there are 2-point charges. So plus 4Q and Q. So here I will take plus 4Q, here plus Q. They are separated by distance R. So distance between these two is R. Where should third point charge Q should be placed so that whole system remains in equilibrium. Now both are positive. So third charge has to come in between these two charges. That is in between these two charges, and it will be near to smaller one in magnitude. Near to smaller one. So now if I take here as a midpoint, so Q should come somewhere here in between this, you will have plus Q. So means its distance should be less than R by 2 from Q. So if you check the options, 2R by 3 from Q means it will come near to 4Q. So this is not the answer. R by 3 from Q means it will come to the nearer to this one. So B is your answer. So R by 3 from Q. Next, second one. Two identical spheres having charge 16 microcoulomb and 8 minus 8 microcoulomb are kept at a certain distance apart, then force is F. So this I will take it as 16 microcoulomb. Another one is having charge minus 8 microcoulomb. Let the distance between these two is R. Then the force between them. So F I will take. F is proportional to 16 into 8 divided by R square. Now they are touched and again kept at same distance. So when you touch the both spheres, when you touch, there is redistribution of charge. So there is redistribution of charge. You should take algebraic sum of these two. So 16 minus 8, 8 remains, and this 8 microcoulomb is equally divided among both. So 8 microcoulomb is equally divided among these two. So here you will have 4 microcoulomb, 4 microcoulomb. Distance is same. So this distance is again R. So now F dash is proportional to Q1 into Q2. So 4 into 4 divided by R square. You are required to find F dash. So now take the ratio. So F dash by F will be equal to 4 into 4 divided by 16 into 8. R square gets cancelled. So if you simplify, 16 gets cancelled. So you'll have F dash is equal to F by 8. F dash is equal to F by 8. So option C is the answer. Next, third one. A deuteron and alpha particle are placed in an electric field. So deuteron is there, alpha particle is there. They are placed in an electric field. The force acting on them are F1 and F2. Then you are required to find their acceleration. Then he has given the options. So first, if I take a deuteron means you will have its formula as 1H2 alpha particle. Alpha particle is helium nuclei 2He4. So they are placed in an electric field, the force acting on them and acceleration he has given. So acceleration of charged particle in an electric field is given by A is equal to QE by M. Now they are placed in same electric field, so E is constant. So you can say A is proportional to Q by M. A is proportional to Q by M. So first if I take neutron, its acceleration A1, if I take its charge Q1 is equal to 1e. If you take mass, it is 2m I will take. Mass number is 2, so mass I will take it as 2m. Acceleration of alpha particle A2, charge of alpha particle atomic number is 2, so 2e. Mass of alpha particle, that is m2, atomic number is 4, so mass will be 4. Now I will take acceleration ratio, then we will check force. So if I take A1 by A2 is equal to Q1 by Q2 into M2 by M1. Now substitute. Q1 is E, Q2 is 2E, M2 is 4M and M1 is 2M. So E and M gets cancelled, you will have ratio as 1, which implies A1 is equal to A2. A1 is equal to A2. So option is C. So A1 is equal to A2. Clear, students? Next, fourth one. A uniformly charged conducting sphere is having radius 1 meter and surface charge density 20. The total flux leaving the Gaussian surface enclosed in the sphere. So the total outward flux is given by 1 by epsilon naught summation Q. Now here instead of Q he has given charge density. So this becomes sigma into 4 pi r square by definition of charge density divided by epsilon naught. Now substitute the values he has given. So now if you substitute, so sigma he has given as 20 into 4 pi into r he has given as 1 square divided by epsilon naught. So we will have answer as 80 pi divided by epsilon naught. 80 pi divided by epsilon naught. So option B is the answer. Next, fifth one. A point charge of 6 microcoulomb is placed at a distance 20 centimeters directly above the center of a square of side 40 centimeter. So magnitude of flux through this square is. Just to understand, imagine students. So first there is a square. There is a square. Charge is placed at a distance 20 centimeter exactly above this center. So here charge is there. So 6 microcoulomb. This is 20 centimeters. Its side is 40 centimeters. That of square. Now you develop this as a cube so that charge comes at the center. So rough if I take, so somewhat in this form you will have cube where charge is exactly at the center. Charge is exactly at the center. So charge becomes exactly at the center of this cube. So now total flux out of this cube will be, now it is symmetric because charge is at the center 20 centimeters below, 20 centimeters above you will have the face of cube, right, left, the distance from all the faces is same. So total flux from this cube is given by 1 by epsilon naught summation q. So that is 6 into 10 raised to minus 6 divided by epsilon naught. Now, he has asked us to find flux through this square. Through this square. So it is having 6 faces. So it is equally distributed. So 1 by 6th flux of Q. So it is divided by 6. So you'll have answer 1 into 10 raised to minus 6 divided by epsilon naught. The flux will be equally passing out through each face. So one face means it becomes a square. So 1 into 10 raised to minus 6 by epsilon naught. So option D is our answer. Option D is the answer. Next, sixth one. It is theoretical. Which of the following is true for electric flux through a Gaussian surface? So it depends on magnitude of charge. Yes, correct. Because flux is given by 1 by epsilon naught summation q. So it depends on charge. Flux is a scalar quantity. Yes, correct. Flux we take it as E dot ds. So it is scalar product of E and ds. See, flux is independent of Gaussian surface. Yes, that is also true. It depends upon charge enclosed but not on the surface. So this is also true. So option all are true is the answer. All are true is the answer. Next one, seventh. Two negative and equal charges A and B are fixed at a certain distance. So two negative charges are there. Both are identical, equal charges he says. So minus q and t. They are separated by distance d. Third charge may be placed. Third charge may be in equilibrium at a position. So if you see the options clearly, you can say that if you keep a charge at midpoint of these two, so the electric force between these two charges and these two will be same because magnitude are same. Here if I take F1, here if I take F2. So F1 will be equal to K Q into capital Q divided by D by 2 bracket square, and F2 also will be same, that will be also again equal to F2. So both are equal and opposite. So capital Q will be in equilibrium. So option is midpoint between two charges. Midpoint between two charges. Next, eighth one. The linear charge density on a semicircular ring in magnitude is the same. So if you observe the figure, linear charge density is same, he says. Here if it is lambda, here also it is lambda. Only thing is quarter circle is positive, quarter is negative. You are required to find electric field at the center. So electric field due to these positive charges will act away from positive. So it will be in this direction. I will take this as E. So exactly at the center of this quarter circle means this angle is 45 degree. So this angle is 45 degree. Now electric field due to this negative charge, it also will be acting exactly at the center and its value will be also E, while this is directed towards negative charge due to positive is away. So this angle is also 45. So if you observe both are equal, so resultant will act exactly at the center. So resultant will be exactly at the center. So that is along a negative y-axis. So along a negative y-axis. So option D is the answer. Option D. Clear, students? Next one. Next, the dipole moment of system is. So now if you observe, it is an equilateral triangle. Now here one dipole will be there. Minus 3 is written as minus 2. Here plus 2q. So direction is from negative to positive. Another dipole will be formed by this q charge. So here minus q. Here plus q. So it will be acting from negative to positive. As it is an equilateral triangle, the angle is 60. So if I take this as P1, dipole moment, distance into charge. So this will be 2q into x. Similarly, between these two, if I take, it will be q into x, that is P2. That is P2. Now I will find resultant dipole moment. So resultant or P net is equal to root of P square plus Q square plus 2PQ cos theta. So I will take 2 square plus 1 square plus 2PQ into cos 60. Then I will write outside the root, that is Q into X. So now simplify this. So this is equal to root of 2 square is 4, 1 square is 1, 4 cos 60 is 1 by 2 into qx. So you'll have answer. So this gets cancelled. 2, 2, 1, 3, 4, 3, 7, root 7 qx is the answer. So option A is the answer. Option A is the answer. Next, 10th one. The flux of electric field through this hemisphere surface. So now this hemisphere is placed in an electric field. So total flux through this is equal to 0 because total number of lines incoming is equal to outgoing, or you can say no charge is enclosed inside this. So now this is divided into two. One, flux through circular surface plus flux through hemispherical surface is equal to 0. Now, if I take circular surface, so circle it is in this form, E is acting upwards, normal to this surface is also parallel to E, this is normal, parallel to E, therefore theta will be equal to 0. So flux is given by E cos theta into ds. E cos 0 is 1. Area of a circular face is given by pi r square. Pi r square. So if I substitute here, it is E into pi r square plus flux due to hemispherical surface is 0. So if I take flux through hemispherical surface is equal to minus E into pi r square. So here he has taken magnitude, means it will be negative. So here among these options, E into pi r square is option A. Option A. Clear, students? Okay. So again further from 11 to 20 I will be taking in next video.